Hello dear students, welcome to the live. Today we will see ISRO PYQs. Okay. Let us see the first question. Modular ratio M for M25 grade of concrete. They are asking modular ratio for M25 grade concrete. You know, for M25 grade concrete, sigma CBC value from the table is 8.5. 8.5 Newton per mm square. Now, modular ratio M equals to 280 upon 3 times sigma CBC. That is 280 upon 3 times sigma CBC. Here sigma CBC value 8.5. So, it is a 280 upon, let us take this value nearly 9, say 27. So, this value will be very close to 10, not exactly 10, very close to 10, just above the 10. If I observe the options here, just above the 10, there is only one option, that is option C, 10.98. Its value is 10.98. Option C is correct. Then move to next question. Permissible deviation from specified dimensions of cross section of column and beams as per standards is IS code recommended deviation for columns and beams, my dear, plus 12 mm to minus 6 mm, plus 12 mm to minus 6 mm. Next question. The modulus of rupture of concrete in terms of its characteristic cube compressive strength FCK in megapascal according to IS 456-2000 is, they are asking modulus of rupture. Modulus of rupture also called flexural tensile strength of concrete, that is 0.7 root FCK as per present code, that is option D is correct. Okay. Then move to next question. For limit state of collapses, the partial safety factor recommended by IS 456-2000 for estimating the design strength of concrete and reinforcement steel are respectively. They are asking what is the partial safety factor for concrete and partial safety factor for steel. For concrete under limit state method 1.5, for steel under limit state method, my dear, 1.15. So, option is 1.5 and 1.15. Option C is correct. Partial safety factor under limit state of collapse for concrete 1.5, for steel 1.15 recommended by IS 456-2000. Next question. In the limit state design of a flexural bending, the maximum strain in the concrete at the outermost compression fiber is, my dear, under flexure, the maximum strain in concrete will be 0.0035. This is under bending moment. Under axial force, maximum strain in concrete will be 0.002 under axial compression. Under axial compression and bending moment, the maximum strain in concrete should not be more than 0.0035 minus 0.75 times epsilon m. Okay. And the strain in tension steel should be 0.002 plus 0.87 Fy upon Es. And one more, the strain in compression steel will be 0.0035 into 1 minus d dash upon xu max. And shrinkage strain in concrete will be 0.0003, or you can say 3 into 10 to the power of minus 4. My dear, shrinkage strain in concrete under post tensioning method is 2 into 10 to the power of minus 4 upon log base 10 into t plus 2. Out of this, one compulsory in exam. Here they are asking bending, flexural bending. So take it, strain in concrete should be 0.0035. Okay, one question compulsory from this. Right. Next one, next question. The final deflection of a structure due to all loads, including the effects of temperature, creep and shrinkage, and measured from the as cast level of supports of floor, roofs and all other horizontal forces should not normally exceed. My dear, this downward deflection under loads as well as under secondary effects should not be more than span upon 250. Under loads as well as under secondary effects. The secondary effects like shrinkage, creep, temperature change, these are the secondary effects. Okay. Next one, the deflection should not be more than span upon 350 or 20 mm, whichever is smaller. This is only under secondary effects. Deflection should not be more than span upon 350 or 20 mm, whichever is smaller. But here they are asking the deflection under loads as well as under secondary effects. So it should not be more than span upon 250. Option B is correct. Next question. Minimum cement content, maximum, they are asking minimum cement content, then maximum water cement ratio, and minimum grade of concrete, with a nominal weight of aggregate of 20 mm size for a very severe exposure condition as per IS 456-2000 respectively. Exposure condition. IS code recommended different grades of concrete based on exposure condition for mild, moderate, severe, very severe, very severe, then extreme exposure condition. For mild, my dear, minimum cement quantity 300 kgs per cubic meter of concrete, 300 kgs, moderate 300 only. For severe 320 kgs, for very severe 340 kgs, for extreme 360 kgs. Okay. Then maximum water cement ratio 0.4, 0.45, 0.45, 0.5, then 0.55, maximum water cement ratio. Coming to the minimum grade of concrete, say it is M20, M25, M30, M35, M40, minimum grade of concrete. They are asking for very severe exposure condition. Minimum quantity of cement 340 kgs per cubic meter of concrete, and maximum water cement ratio 0.45, and minimum grade of concrete is M35. Now check it, 340, 0.45, M35. Option A itself correct. Okay na? Right. Next question. The dimensions of specimen taken for estimation of 7-day compressive strength of concrete is, my dear, standard size of cube we can use to determine the strength of the concrete. Whether you test at 3 days, or you can test at 7 days, or you can test at 28 days. Same size of cube only we can use it. Its dimension is 15 centimeter 15 centimeter by 15 centimeter. Here cube means all dimensions are same. If you write in mm, you will get, my dear, 150 mm by 150 mm by 150 mm. This is the cube. There are three different sizes of cubes. 15 centimeter size cube. It is used to determine strength of concrete. Concrete strength. To decide concrete strength, we can test 15 centimeter size cube. Other one is 10 centimeter size cube, which is tested to decide cement grade. Cement grade, 10 centimeter size cube. And other one is that 7.06 centimeter size cube. My dear, it is used to decide, this is grouting material strength. A small correction, this is for grouting material strength. 10 centimeter size cube is tested to decide grouting material strength in post-tensioning method. Grouting material strength. To decide grouting material strength. 7.06 centimeter size cube is used for a cement grade, for deciding cement grade, whether it is 33 grade cement or 43 grade cement or 53 grade cement. To decide grade of cement, we can use 7.06 centimeter. Out of the three, one question you can expect in exam. Okay, anyway, here clearly mentioned that concrete. So, to decide strength of concrete, you can select a standard size of cube 15 centimeter by 15 centimeter by 15 centimeter or 150 mm by 150 mm by 150 mm. Next one, cylindrical specimens of diameter 150 mm and height 300 mm are used to estimate. My dear, actually Indian standard code follows cube test results. American code follows cylinder test results to determine compressive strength of concrete. But we take cylinder test results for determining split tensile strength. Okay. Cylinder is used to determine split tensile strength of concrete. Next one, FE 415 in RCC construction implies, my dear, FE 415 comes under HYST. HYST bars. So, full form of HYST is high yield strength deformed steel bars used in RCC. Okay, option B is correct. Next, when the effect of wind is considered for a design in addition to dead, live and impact load, the permissible stress in concrete may be exceeded up to a limit of, my dear, whenever structure subjected to wind load, earthquake load, in addition to dead load, live load, then you can increase the permissible stresses in concrete and steel by 33.33% as per IS 456-2000 recommendations. Next question. The Indian Standard Code of Practice for plain and reinforced concrete. What is the reference code used for RCC? My dear, IS 456. This is the reference code for plain concrete and reinforced concrete. If you want to check the permissible limits, which is given in IS 456. Okay. Now, IS 875 is for loads. Suppose if you want to design a structure, definitely loads is the criteria. Now take it dead load, live load, wind load, like that. So, here you can take it, my dear, IS 875 is a reference code. IS 800 is the design of structural steel. Design of structural steel. Steel structures, if you want to design, use the reference code is, my dear, IS 800. But for the given question, option A is correct. This is for steel structures. Okay, right. Next question. the compressive strength of 100 mm cube of concrete as compared to 150 mm. There are two different sizes of cubes we are comparing. One is 15 centimeter size cube. The other one is 10 centimeter size cube. 10 centimeter size cube. My dear, no doubt 10 centimeter size cube is stronger than 15 centimeter size cube. Why means it has better homogeneity compared to bigger size cube. It has better homogeneity, less voids. That's why strength will be more. So here strength will be more. Strength will be more compared to 150 mm size cube. 100 mm size cube will be stronger. Next, the individual variation between test strength of concrete cube sample should not be more than. My dear, if you take a random sampling test procedure, the number of specimens, one sample consists of 3, and the individual variation of these specimens should not be more than plus or minus 15% of the mean strength. What does it mean? One sample means 3 cubes. One sample means 3 cubes, and the variation of the strength should not be more than plus or minus 15% of the mean strength. Okay. So option C is correct. Option C is correct. Okay, na? Right? Fine. Next one. Nominal mixes may be used with the permission of engineer in charge for grades of concrete. Of, my dear, up to M20 grade concrete, you can go for a nominal mix. Up to M20 grade concrete, you go for nominal mix. Above M20 grade concrete, you go for a design mix. Go for design mix. Is it clear? Up to M20 grade concrete, we go for a nominal mix. Above M20 grade concrete is your requirement, then you go for a design mix. So they are asking for a nominal mix. So for nominal mix, M20 grade concrete or lower grades like M15, M10, we go for nominal mix. Above M20 like M25, M30, M40, M50, we go for design mix. Next question. Under transient wind load, the lateral sway at the top of RCC structure shall not exceed. The lateral sway should not be more than h upon 500. Height of the structure upon 500. Under wind load, the lateral sway should not be more than h upon 500. It is from IS 456-2000. Next one. Modulus of elasticity of M25 concrete as determined by formula of IS 456-2000. Modulus of elasticity of concrete is 5000 root FCK. Here given grade of concrete M25. For M25 grade concrete, FCK value will be 25 Newton per mm square. Now substitute 5000 root FCK value 25. So you will get 25,000 Newton per mm square, or you can say 25,000 megapascal. 1 megapascal equals to 1 Newton per mm square. Right. Option D is correct. Next question. As per IS 456-2000, maximum cement content in RCC shall be. My dear, maximum quantity of cement should not be more than 450 kgs per cubic meter. If you provide more than this, cracks will develop. Okay, it should not be more than 450 kgs per cubic meter for RCC. For prestressed concrete, it should not be more than 530 kgs per cubic meter. Okay. Anyway, they have asked for RCC, so option A is correct. Next question. For cantilever beam, main reinforcement is placed at Suppose you take a cantilever beam. Where do you place the main reinforcement in cantilever beam? This is the longitudinal axis. Actually, for cantilever beam, tension develop above the axis, compression develop below the axis after loading. So, we can provide the main reinforcement, at the top, because tension will develop at the top. So, option C is correct. For cantilever beam, main reinforcement is placed at the top. Why at the top? Because tension develop at the top. For simply supported beam, main reinforcement provided at the bottom, because tension develop for simply supported beam at bottom. Next one, in normal circumstances where ambient temperature does not fall below 15 degrees centigrade, for a properly cured reinforced concrete slabs spanning up to 4.5 meter span cast using ordinary Portland cement, the props provided can be removed only after a minimum period of, actually for columns, even for walls, even sides of beam, you can remove after 24 hours. Okay. Coming to the next one, soffit formwork for slabs. First we have to remove, my dear, you can remove it within 3 days. After 3 days you can remove. Then soffit formwork for beams, you can remove it after 7 days. After removing the soffit formwork, then you have to refix the props. Now you can remove the props also. Props you can remove first for a slab. That is, that depends on the span. When span is up to 4.5 meter, span is more than 4.5 meter. Up to 4.5 meter, it is 7 days. More than 4.5 meter, if a shorter span of slab you can take it. If it is more than 4.5 meter, 14 days. Next, props we can remove for beams. It depends on the span. When span is up to 6 meters, it is 14 days. Now, span more than 6 meters, you can remove after 21 days. But here the question is, the props provided can be removed for what? For a slab, right? Spanning up to 4.5 meters. So, 7 days. Option B is correct. What will be the stripping time for the formwork? When will you remove the formwork? Right. Next one. The characteristic load means the value of load. It is a standard definition. Characteristic load is the value of load which has 95% of probability of not being exceeded throughout design life of the structure. Here given that which has a 95% of probability of not being exceeded. Option B is correct. Direct definition only. Next question. What is the ratio of flexural strength FCR to the characteristic compressive strength of concrete FCK of M25 grade concrete? What will be the ratio of FCR upon FCK? Here FCR is 0.7 root FCK upon FCK. 0.7 root FCK for M25 grade concrete is 25 upon FCK 25. You will get this one is 3.5 and this one is 25. Now simplify. 5.7 are 5 5s are. So I can write it is 7 by 50. 57.0. 50 ones are 50. Then 20. One more 0 you can put. 4s are 200. So 0.14. 0.14. The ratio we are getting 0.14. Okay. Option C is correct. Next question. As per Bureau of Indian Standard Code 456-2000, deformed bars may be used without end anchorages. Basically, over the surface of deformed bars, corrugations are present, rings are present, ribs are present. Due to this, bond strength will be very high. So, it will satisfy the bond criteria. However, if it is not satisfied the development length, definitely you can provide the end anchorages even for a deformed bar. Generally required this end anchorages for mild steel because the bond strength will be less, grip will be less, chances are more to slip the bar from concrete. But HYST bars will have more grip with the concrete. So no need basically. If required, you have to provide. Here given that as per Bureau of Indian Standard Code 456-2000, deformed bars may be used without end anchorages provided when development length required is satisfied, then no need of end anchorages. If development length criteria not satisfied, you can provide end anchorages even for HYST bars. Next one, a simply supported beam has an effective span of 16 meters. What shall be the limiting ratio of span to effective depth? What shall be the ratio of effective span to effective depth? Actually, span given that more than 10 meters, that to mention simply supported. For simply supported beam, span to depth ratio, if span is more than 10 meters, will be 10 upon span into 20. That is 10 upon span given 60 into 20. Now 4 5s are 4 5s are 4 5s are. It is 4 5s are 4 4s are and 4 5s are. Next 4 1s are 4 2.5s are. So you will get 12.5. 5 2s are 10. 5 halves are 2.5. So 12.5. Option C is correct. Option C is correct. Okay, right. Next one. Next question. For a design of flexural members, the strain in the reinforcing under tension at ultimate state as per IS 456-2000 shall not be less than. They are asking what is the strain in tension steel. 0.002 plus 0.87 Fy upon S. How do you get 0.87 Fy? Simply if you take the partial safety factor for steel 1.15. So you can write down this one as Fy upon 1.15 into S. Okay, option B is correct. Next question. The minimum area of tension reinforcement of steel P in a singly reinforced beam of width B and effective depth D. What is the minimum tension reinforcement? You will get from this formula AS upon BD equal to 0.85 upon Fy. You want AS? Okay, AS equals to 0.85 BD upon Fy. 0.85 BD upon Fy. Option A is correct. Option A is correct. Okay. Next question. The load at the free end of a uniform cantilever beam is increased, the failure will occur at whatever the load you can increase at the free end. Definitely maximum moment will develop at the fixed support. So failure you can expect at the fixed support. Option B is correct. Next question. The maximum area of compression reinforcement in a beam of cross section B by D is limited to, very important, maximum tension steel in the beam should not be more than 4% of gross cross sectional area. maximum area of compression steel in beam should not be more than 4% of gross cross-sectional area. Maximum steel in slabs should not be more than 4% of gross cross-sectional area. Maximum area of steel in columns should not be more than 6% of gross cross-sectional area of the column. Right? Important. You can expect any one in the exam. Maximum tension steel in beam, maximum compression steel in beam, maximum tension steel in slab, and maximum steel in columns. Okay, here they have asked in beam, compression steel, my dear, 4%. 4%. Next one. The section in which concrete is not fully stressed to its permissible value. That means stress in concrete less than permissible stress. When the stress in steel reaches to its maximum value, stress in steel reached to its permissible value is called. So, which section is it? My dear, it is under reinforced section. In under reinforced section, stress in steel reaches to its permissible value, but stress in concrete does not reach to its permissible value because area of steel is less in under reinforced section. So, stress in steel will move at faster rate, but stress in concrete moving slowly. That is why steel fails first. Under reinforced section is the correct one. Next one. The effective depth of a singly reinforced rectangular beam is 400 mm. Effective depth given 400 mm. The section is over reinforced, okay, and the neutral axis is 180 mm. X given 180 mm. If the maximum stress attained by concrete is 5 Newton per mm square, stress in concrete given 5 Newton per mm square, and the modular ratio is 18, M given 18. Then the stress developed in the steel would be, my dear, this type of questions easily you can solve by drawing the stress diagram. Okay, maximum stress they have given 5 and they are asking what is the maximum stress in steel. Stress in steel you can write in terms of concrete, okay. That is divided with the modular ratio. Here modular ratio given, you can write directly modular ratio, it is 18. Now anyway join these two and they have given that depth of neutral axis will be 120 mm. Is it 120? No, 18. Yeah, depth of neutral axis is 180 mm. Okay, it is 180 mm. Now what is the overall depth of the beam given? 400. If it is 400, then what will be this depth? 220 mm. 220 mm, right? Okay, use similar triangle property, you will get T by 18 upon 220, which is equals to 5 by 180. Okay, now 0, 0 gets cancelled. You will get from this T equals to 5 by 18 into 5 by 18 into 22 into 18. So, this 18 gets cancelled. 5 into 22. 5 2s are 10. 1. 5 2s are 10. 110. So, 110 be the answer. Option A is correct. 110 megapascal. 110 megapascal. Next question. Tension failure occurs in a singly reinforced beam. My dear, tension failure occurs. Actually, we have 3 types of sections: balanced section, under reinforced section, over reinforced section. In balanced section, both materials will fail simultaneously. Concrete and steel, both will fail simultaneously. But in under reinforced section, steel fails first. In over reinforced section, concrete fails first. Let us come to under reinforced section. Steel fails first under tension. That's why it is also called tension failure. So, under reinforced beam. In a singly reinforced beam, the effective depth is measured from its compression edge to effective depth definition is distance between extreme compression fiber to centroid of tension steel. Extreme compression fiber to till centroid of tension steel. So, option D is correct. Option D is correct. Extreme compression fiber to till centroid of tension steel. Next question. A reinforced concrete beam has cross-sectional dimensions of 300 mm by 1000 mm. Assuming M25 grade and Fe 500 grade steel, the cracking moment at the section is, my dear, cracking moment we can determine like this. Cracking moment equals to FCR upon YT into IGR. Easy to remember, you know flexor formula, M by I equals to F by Y equals to E by R. Same, you can remember that formula, but for cracking moment, the stress will be FCR. Okay, whenever stress reaches to FCR, then cracks will develop. Okay, so you will get cracking moment here. FCR will be 0.7 root FCK. Here M25 grade concrete given, so FCK will be 25 upon Y is half of the total depth. Total depth is 1000, so I can write down it is 1000 by 2 into IGR. IGR, it is a rectangular cross section, so moment of inertia about neutral axis will be BD cubed upon 12. BD cubed upon 12. BD cubed upon 12. Okay, right. So you can write this value again 0.7 into root 25 is the 5. Okay, upon this is 500 into 300 into 1000 into 1000 square, I can write down 10 power 6. Keep it like that only. 500 ones are, otherwise 5 ones are 500s are, 100 ones are 100 tens are, and by 12 is remaining. By 12 is remaining. Correct, na? So what is remaining now? Still remaining is what? 2 6 jar to 150 jar. Still remaining. Okay. 3 2s are 350s are still remaining. Okay. It is 2 1s are 2 5s are. So 250 into 0.7. 250 into 0.7. 250 into 0.7. Na? Otherwise, I can write down 25 into 7. 7 5s are 35. 3. 7 2s are 14. 14 and 3. 17. 175. Is there? Yeah. Option A is correct. 175 into 10 power 6. Next question. The ultimate moment of resistance of a beam with B equals to 300 mm, AST equals to 600 mm square, Fy 500 and lever arm Z equals to 300. They are asking moment of resistance. We can find with respect to tensile force. It is 0.87 Fy into AST into Z. My dear, 0.87 Fy given 500, AST given 600, Z will be 300. So how do you simplify? Here 2 zeros, here 2 zeros, here 2 zeros, take outside. You will get into 10 power 6. Now 3 6 are 18. 18 5s are 90. 90 into 0.87. I can take a round figure 0.9. So 9 into 9, 81. 81 into 10 power 6. Answer is very close to 81. Very close to 81, but less than 81 because this value is 0.87 actual value, but I have taken a higher value. So I get a higher value. Less than 81 is the answer. Very close to 81, but less than 81. Option C is correct. Option C is correct. Next question. If D and N are the effective depth and depth of neutral axis respectively of a singly reinforced beam, the lever arm of the beam is, they are asking lever arm. Basically, we can get lever arm Z equals to D minus XA upon 3 or XC upon 3. I can write right now X upon 3. Instead of X, they have given a notation N. So, D minus N upon 3. Option D is correct. Okay, right. Next question. In the case of a continuous beam, if the width of support is less than 1/12 of clear span, then the effective span shall be calculated as, it is similar to the simply supported beam. Whenever width of support for a continuous beam is less than 1/12 of clear span, then the effective span calculation is, my dear, it is similar to simply supported beams, that is L plus Bs by 2 or L plus D by 2, whichever is smaller. Here given L means clear span plus effective depth or center to center distance of supports, whichever is less. Option C is correct. Option C is correct. Next question. In an under reinforced RCC beam section, the actual neutral axis falls dash the critical neutral axis of a balanced section. Suppose you take the cross section of beam. This is the critical neutral axis position. This is actual neutral axis position. This is XA and this is XC. XA less than XC. But the question is XA greater than XC or XA less than XC. It is not the question. Question is actual neutral axis lies above the critical neutral axis or below the critical neutral axis or exactly at the critical neutral axis. My dear, for this case it is above. Actual neutral axis lies above the critical neutral axis. This is actual neutral axis. This is critical neutral axis. Next one. If the span to effective depth ratio of a simply supported beam for span up to 10 meters, and given that it is simply supported beam, does not exceed for vertical deflection limit. My dear, span to depth ratio for a simply supported beam is 20 when span is up to 10 meters. When span is up to 10 meters, L by D ratio is 20. Next question. A doubly reinforced section is used when the members subjected to external loads and bending moment in the section reverses. That means when beam subjected to reversal of stresses. When the members are subjected to loading eccentric on either side of the axis. Yes, next. When the members are subjected to accidental lateral loads. Yes, all the above. Option D. In all situations, we go for doubly reinforced beams when members subjected to reversal of stresses, when members subjected to lateral loads, when members subjected to accidental loads, that is the impact load. We can go for a doubly reinforced beam. Option D correct. Next question. A simply supported beam is considered as a D beam if the ratio of effective span to overall depth is less than L by D not greater than 2. For a simply supported beam, then consider it is a D beam. For a continuous beam, L by D ratio not greater than 2.5, consider it is a D beam. Okay, right. Option B is correct. For simply supported beam, L by D ratio not greater than 2, then it is a D beam. In an RCC beam, side face reinforcement is provided if the depth of web exceeds 750 mm, when member is subjected to only flexure, provide side face reinforcement. Suppose when member is subjected to torsion, if depth of web is more than 450 mm, you can provide the side face reinforcement. Okay, check it whether member is subjected to flexure or member is subjected to torsion. Nothing is mentioned in the question, flexor or torsion. So consider member is subjected to flexor only. Okay, option D is correct. Next question. A doubly reinforced section is used when additional safety is needed. B. Beam has to resist high bending moment. C. Beam has to resist tension at the top and bottom face. Size of beam is restricted. Yeah. When size of beam is restricted, we go for a doubly reinforced beam. Next one. A T-beam behaves like a rectangular beam of width equal to its flange if its neutral axis. My dear, whenever neutral axis lies within the flange, then it will behave like a rectangular section. This is the neutral axis. When neutral axis lies within the flange, then it will behave like a rectangular section. Okay, so within remains within the flange. When a flange section behaves like a rectangular section. Simple. Whenever a neutral axis lies within the flange, then a flange section behaves like a rectangular section. Option B is correct. Next question. When the depth of web in a RCC T-beam exceeds side face reinforcement shall be provided. My dear, already discussed, when depth of web exceeds 750 mm, we go for side face reinforcement. Next question. If phi is the nominal diameter of reinforcing bar, Fx is compressive stress in the bar and FBD is the design bond stress of concrete, the anchorage length LA of a straight bar in compression is equals to, my dear, that is equals to LD equals to phi into sigma st upon 4 times tau BD. Direct formula. Phi into sigma st upon 4 times tau BD, but notations they have changed here. That's the only difference. Option D. The radius of a bar bent to form a hook should not be less than. If it is a mild steel, we can take twice the diameter. If it is HYST bar, we can take 4 times the diameter. But it is not mentioned here mild steel or HYST bar. So consider bend or hook required for mild steel. So take it twice the diameter. Option A is correct. Next question. If the bond stress developed in a reinforced concrete beam is more than permissible value, it can be brought down by. Bond stress is more than permissible value. How can we brought down by? Simple, you can choose a smaller diameter than the larger diameter. Choose a smaller diameter then design diameter. Suppose you have selected 20 mm dia. Instead of 20 mm dia, you can go for a smaller diameter, 16 mm or 12 mm. Then it will satisfy the bond criteria. Option C is correct. Next question. Shear reinforcement in a RCC beam is provided to resist. Shear reinforcement in a RCC beam is provided to resist, mainly to resist diagonal tension. Shear reinforcement is provided in RCC beam mainly to resist diagonal tension. For bending, basically for bending stress and compressive stress, we have to provide longitudinal steel, but shear reinforcement will take care of diagonal tension. The maximum spacing of vertical shear reinforcement shall be not more than 0.75 D or 300 mm. 0.75 D or 300 mm. Take whichever is smaller. This will be the maximum spacing for vertical stirrups. For inclined stirrups, maximum spacing will be D or 300 mm. D or 300 mm, whichever is smaller. For vertical stirrups, here given maximum spacing should not be more than 0.75 D. Option B correct. Next question. For a simply supported beam of a span 5 meters, width 300 mm, span 5 meter, width 300 mm and depth is 500 mm. Carrying a factored uniformly distributed load of WU given 10 kilonewton per meter including self-weight, the nominal shear stress will be, how do you get nominal shear stress? Tau equals to VU upon BD, correct na? Yes or no? Right. Here VU we need, B given, D given. How do you get VU? WL by 2. For a simply supported beam, it is WU into L by 2. WU is 10 and L will be 5 meter by 2. So 2 1s are 2 5s are. You'll get 25 kilonewton. We want nominal shear stress tau V, which is VU upon BD. Now VU is 25 kilonewton. You can write in Newton upon BD. B is 300 mm, D is 500 mm. Now 500 ones are 500 twos are, right? This is 50 by 300. 50 by 300. So 0 0, 5 ones are 5 6 are. So 1 by 6 value. 1 by 6 0 0.1 6 4 0 6 36 again 4 0 6 36 okay 0.166 or 0.167 you can take it. Option D is correct. Option D is correct. Next question. As per IS 456, splicing shall not be used for bars larger than dia. My dear, splicing should not be done when bar diameter is more than 32 mm. When bar diameter more than 32 mm, we can go for welded joints. Okay. Previously given 36 mm in code, later it is modified to 32 mm. 32 mm is the correct one. Option D. Next question. The minimum diameter of longitudinal reinforcement in a column as per IS 456-2000, 12 mm. Minimum diameter we use for longitudinal steel in column is 12 mm. Next one. The maximum cross-sectional area of longitudinal bars permissible in a column as per IS 456-2000. Maximum longitudinal steel provided in columns will be 6% of gross cross-sectional area of the column. Next question, a structural member subjected to axial compressive force only. My dear, beam subjected to flexure. Axial compression will be there, but we don't consider. Coming to the column, now column subjected to axial compression, even bending moment also based on the position. Now strut is subjected to only axial compression. Option B is correct. Which member subjected to only axial compression? Only axial compression possible in strut. In case of a rectangular foundation, width equals to B, the maximum permissible eccentricity of load is limited to, maximum eccentricity is limited to B by 6. Next one, in a reinforced concrete retaining wall, a shear key is provided if the, my dear, if the retaining wall is not safe against sliding, then we provide shear key. Next question, the critical section for evaluating the bending moment for an isolated footing is at, the critical section for bending moment lies exactly at the face of the column. Next one, as per IS 1893 Part 1 2002, Bangalore falls under which earthquake zone? Zone 2. In limit state method of design approach, spacing of main reinforcement primarily controls, maximum spacing primarily controls cracking. Option B. As per Indian standards, linear dynamic analysis shall be performed to obtain the design lateral forces for all buildings, my dear, regular buildings lower than 15 meters in seismic zone 2. Next one, the minimum reinforcement in slabs should not be less than -% of the total cross-sectional area when HYST bars are used in either direction. My dear, when we use HYSD bars, the minimum steel should be 0.12% of gross cross-sectional area of the slab. If we use mild steel in design, then take minimum steel should be 0.15%. Here clearly given HYSD bars, so option B is correct. Next question, when design imposed load does not exceed 3/4 of the design dead load, the load arrangement on structural frame, you can arrange, my dear, in all spans. You can arrange in all spans. Next question, the main reinforcement of a slab of width equals to 1/3 of its overall length is provided along, my dear, along the shorter span. Along the shorter span, you can provide always main reinforcement in slab, whether it is a one-way slab or it is a two-way slab. Next one, the analysis of slab spanning in one direction is done by assuming it to be a beam of, my dear, one-way slab is treated like a beam whose width is 1 meter, 1 meter width. A reinforced concrete slab is 75 mm thick. The maximum size of reinforcement bar that can be used is, maximum diameter of the bar should not be more than 1/8 of overall thickness, should not be more than 75 by 8. That means not more than 9.375 mm. So pick up 8 mm, not more than 9 mm means less than 9 mm, that is 8 mm. Option B correct. Next question, the drops are provided in flat slabs for what? To resist shear. Next question, the horizontal distance between parallel main reinforcement bars shall not be more than dash dash the effective depth of a solid slab. My dear, 3 times D or 300 mm, whichever is smaller. In slabs, maximum spacing of main reinforcement should not be more than 3D or 300 mm. Okay. Next question, for a simply supported RCC folded plate roof which is cast, the formwork is to be removed from, my dear, you can start removal from the support, then you can move towards the midspan, towards the center, both supports, and proceed towards the center. You can remove the formwork at the support, then go towards the center from either side. Next, Ly is the length of the longer span and Lx is the length of the shorter span of an RCC slab. If the slab is to be designed as a two-way slab, then Ly by Lx, for a two-way slab, Ly upon Lx should not be greater than 2, means less than 2. If the slab is to be designed as a two-way slab, less than 2. Option D is correct. Next question, the length to width ratio of slab is, length to width ratio of the slab is 1.3, means less than 2. Less than 2 means it is a two-way slab. It is designed as two-way slab. Next, when the ratio of the long to short dimension of the slab greater than x, Ly by Lx is greater than x, the slab shall be designed as a one-way slab. Then what will be the x value? X value will be 2. Next one, and this type of questions are too lengthy. Don't touch this type of questions. Even without calculator, difficult to solve. As per Indian Standard Code of Practice for Prestressed concrete, IS 1343, the minimum grade of concrete to be used for post-tension and pre-tension structural elements are respectively. First one, post-tensioning. Next one, pre-tension. So, for post-tension, M30. For pre-tension, M40. Option D is correct. Next question. In prestressed concrete, my dear, basically in prestressed concrete, the forces will remain same, but lever arm will be changing. In RCC, opposite, lever arm constant, forces will change. But in PSC, forces remains constant, but lever arm changes. Both forces of tension compression as well as, forces of tension and compression remains unchanged, but lever arm changes with respect to moment. Next question, the permissible value of span to depth ratio will be the highest in the case of, for simply supported 20, L by D ratio, for cantilever 7, For continuous 26. Highest will be for 20. L by D ratio highest will be for C. The pH value of water for quality concrete shall not be less than, pH value of water shall not be less than 6. Okay. I wish you all the best. Questions will be straightforward from this subject. Mostly questions will be codal provision or definitions. In worst case, you can expect concepts. Okay, right.